This video covers section 8.3, which is going to look at inequalities. So a compound inequality is when you have two inequalities joined with and or. And the solution has to work in both equations or has to work in either or both. It could just be one. So for example here is 2x greater than -3 and 2x minus 5. So that with the and is our compound inequality. Now we're going to test if 1 is the solution. So we plug it into the first one. 2 times 1 is 2. Is 2 greater than -3? Yes, so it works in the first one. Now let's plug it in that one. 2 times 1 is 2. Is 2 less than 5? Yes. It works in both, so yes, it is a solution. Okay, now let's look at this one. Or, so it only has to work in one. It could work in both, but it only has to work in one. So if we plug it in the first, 5 plus 2 is 7. 7 is greater than 3. Because it's or, we only have to check one, so it's yes. Let's say we had checked the other one first. 5 minus 1 is less than -5, would be 4. It's not true in that solution, but it doesn't matter because it was true in the other, so it is still a solution to that whole compound inequality. So here, we've got two problems. Each problem has two numbers to try. Pause the video, try them, see if you can figure it out. All right, so for this first one, we're testing 5. So 5 plus 1 is less than 9. 6 is less than 9. That works. 2 times 5 is 10. 10 minus 1 is 9. 9 is greater than 8. So yes, 5 works. 5 is the solution because it works in both. Now let's do -5. -5 plus 1 is -4. -4 is less than 9. 2 times -5 is -10. Minus 1 is -11. That is not true. So because that's not true in both, -5 is not a solution. Now let's look at the next one. All right, we're going to test 2. Is 2 a solution? 5 minus 2 times 2. Well, 2 times 2 is 4. 5 minus 4 is 1. 1 is not less than or equal to -4, but it's an or, so I have to check the other one too. And 5 minus 2 times 2. 5 minus 4, 1 is not greater than or equal to 4, so it doesn't work in either, so 2 is not a solution. Now let's try -3. 5 minus 2 times -3. Well, 2 times -3 is 6. 5 plus 6 is 11. 11 is not less than -4. So we know that one doesn't work. Now let's do the same thing. So notice these are the same. So we're still going to end up with 11. But this time we're saying greater than 4. So is 11 greater than 4? Yes. Because it's or, it only has to work in one. So -3 is a solution. When you see something written like this, that upside down shape, the N, means intersection. It represents and. So where does A and B fit? So if we were graphing on a number line, we'd say, let's say this is -6, -5, -4, -3, -2, -1, 0, 1. Nope, that's not going to do what I want. Let's go by twos. -6, -4, -2, 0, 2, 4, 6, 8, 10. Okay, so I'm going to graph x is less than or equal to 6. So I put a closed circle and point the arrow that way because it's less than. If I were to graph x is greater than -4, I would put an open circle and I would put the arrow that way. Each of those is separate. If I had an and in between those, the intersection and is only where they're both true. So we're going to only draw what overlaps. So we take those endpoints and draw the line in between. If we were writing this in interval notation, open circle, -4, and then this end is a closed circle at 6, so we put a bracket. So the pink is the intersection of those two. All right, so here's where you might see that. Solve it and then graph. So we're going to solve each one and graph them. So if I subtract 4, I get 2x is greater than 4. Divide by 2, x is greater than 2. So if I were to graph this, -2, x is greater than 2. So I'm going to put an open circle and graph it that way. Then we solve this one. So I'm going to subtract 5 from both sides. And we get -x is less than 4. Divide by -1, which is going to flip that sign. So x is greater than -4. So that would be that. And tells us we only graph the part that's both. Well, since that red one goes on forever, really the purple part is where they would overlap. Because if the red kept going, it would overlap on the purple. We just can't count the open circle. So that's how you would graph it. If we were going to write that in interval notation, we start at 2, go up forever. Now this U is the union, is the technical term, but this is where we would do the or. So that means it could be anything on either. So if we were to graph, we'd subtract 2 from both sides. We get x is less than -3. So I would do open circle this way. And then here we would subtract 2 from both sides, and we would get x is greater than -1. And because it's or, it's either arrow. So the or graph would be both, because it could be either. It doesn't have to touch. So interval notation is in either parentheses or brackets. You start with the lowest number, go to the highest number. Arrows represent infinity. If we were to write x is greater than 5, that means we start at 5, go up forever. If we say x is less than or equal to 10, we go down forever, stop at 10, but it can equal 10, so I put a bracket. If I were going to draw this, I would start at 5 with an open circle, 4, 5, 6. Well, let me do this. Okay, so if we start at 5, we have an open circle that goes this way. This one, 10 is a closed circle that goes this way, and is where they overlap. So it would be open circle to closed circle, connect. Because that's one piece, we would write our interval notation with the lowest number and the highest number. If we did one more here, x is less than -1. Sorry, I'm just ignoring that so I can finish this for you. X is less than -1 would look like that. X is greater than 2 would look like that. Because it's or, we leave both of them. All right, interval notation. So lowest to highest would be -2 to 5. That line tells us bracket. Here, x is greater than 3. So our lowest would be 3, and it goes up forever. The next one, we're going down. So less than means we go down forever, end at -5. Or we put that U, and then we start at 2 and go up forever. Greater than 0 and less than 3 means 0 is our smallest, 3 is our highest. And then this last one here, less than 1 would be -infinity to 1, or is U, and then we go 3 to infinity. So those are different ways you're going to see interval notation. Finally, in this section, we look at 3-part inequalities. It's called 3 parts because we have one part here, then an inequality sign, one part here, then an inequality sign, one part here. We solve it exactly the same way. There's just 3 parts. So for example, if we only had this, the first thing we would do is subtract 2 from both sides. 4 minus 2 is 2, and we would get that. Now, with this, the only difference is we just have to do it from all 3 parts. So 8 minus 2 is 6. Now we're left with 2 is less than, or t, which is less than or equal to 6. So our interval notation has the least to the greatest. And then if we were to graph that, 2, 3, 4, 5, 6, we'd have an open circle at 2, closed circle at 6, and they would connect. All right, this one, we have a 3 in front of the z, so to get the z alone, we're going to divide all 3 parts by 3. Negative 3 divided by 3 is negative 1. 3z divided by 3 is z. And 6 divided by 3 is 2. So in our interval notation, we would go from negative 1 to 2. And because of that line underneath, we have the brackets. And then if I were graphing, 0, 1, 2, they would both be closed circles because of the brackets, and that's our line. This last one, same thing. To get rid of the fraction, we're going to multiply all the parts by 2. Negative 5 times 2 is negative 10. Divided by 2 would be negative 5. In the middle, it's just going to cancel out the fraction. 4 times 2 is 8. Now I'm going to subtract 1 from both sides to get the m alone. So we have negative 6 is less than negative m is less than 7. Then we're going to divide everything by negative 1 to make sure the m is positive, which also flips our signs. So if I were to write this, our lowest is actually negative 7, and our highest is 6. So that would be our interval notation. And then on a number line, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. We would have open circles because of the parentheses and connect it. All right, let's look at a word problem. If the ground level temperature is 80 degrees, the air temperature X miles above Earth's surface is cooler and can be modeled by this equation. Find the altitudes at which the air temperature ranges from 42 down to 23. So it's giving us ranges. So we're just going to write a 3-way inequality. 23 is less than or equal to, and then we do the equation, 80 minus 19x is less than or equal to 42. So we take that equation, put it between the 2 ranges, and then solve. So I'm going to subtract 80 from both sides. And I get negative 57 is less than or equal to negative 19x. It's less than or equal to negative 38. I'm going to divide everything, what is going on there, by negative 19 to get the x alone. And I would get 3, remember we're flipping, so greater than or equal to x, greater than or equal to 2. So our interval notation would be 2 to 3. So 2 to 3 miles is when that would work. All right. So try solving this, see how you do, and put your answer in interval notation. So we're going to subtract 1 from both sides. 2x is less than or equal to negative 2. Divide by 2. X is less than or equal to negative 1. As interval notation, that would be negative infinity to negative 1. Then we do the other one. Subtract 1 from both sides. 2x is greater than or equal to 2. Divide by 2. We get x is greater than or equal to 1. So as interval notation, that's 1 to infinity, or is a u. So that's how we write it. All right, the last thing we're going to look at in this section is piecewise defined functions. All the piecewise defined means is there's a different rule. Let me switch colors here. Different rule for each piece of the graph. So here they're saying here's the rule, here's the x values or the domain, the piece of the graph where that rule is true. So if we were looking at this, f of 180, first we figure out which range 180 fits in, which would be this one right here. It's between 157 and 206, and the rule is that it's 4. 157 we see in 2 places. We see it here and here. The difference is this one has that line under, so it can equal 157. So this is the rule for when x is 157. So let's look at how to draw those. So this is our rule from -4 to 2. So our x's are going to range between -4 and 2 for that first piece. And then the second piece is going to go 2 to 4. So the first equation fits in this block. The second equation fits in this block. If I were to graph x minus 1, our y-intercept is -1, so we start there. And our slope is 1, so from that point, we'd go up 1 over 1. And we do the same thing in both directions. Now, we can equal the first, so that's a closed circle. We cannot equal the second, so that's an open circle. Draw our line. Now, the second part is -2x. So our x-intercept is 0. Our slope is -2. So if we were to start it there, we'd go down 2 over 1, down 2 over 1. But we don't care about the first point until we hit that red line. Then we draw the 2 points in the range and connect those. Those are both closed circles because of those lines. So over here, the pink and the blue represent our graph. Now you can leave you don't have to draw those borders if you don't want to. That's completely up to you. You can use them there if they help, but this is the actual graph. Now, looking at the graph, remember the domain is our x values. So our lowest x is -4, and it's closed circle. And then our highest x is +4. So our domain in interval notation would be -4 to 4. Range is our x values, or y values, sorry. So the lowest y is 1, 2, 3, 4, 5, 6, 7, -8, and it's a closed circle. The highest y is 1, but it's an open circle, so we put parentheses. Now we can use that graph to solve some of these equations. So -3, find -3 on the x, go down to our graph, the y value is -4. Ooh, I don't know what I just did there, but I did not mean to. Okay, if we do the next one, f is 2, we go to 2 on the graph. Now here we have 2 points. We have the open circle that's above, and we have the closed circle that's below. The open circle is not our equation, so we're only going to pay attention to the closed circle. 1, 2, 3, 4, meaning it also equals -4. F of 4 means when x is 4, what do we find? So we go down to the bottom there, -8. And then when f is 5, there is nothing. That's not in our domain, so there's no solution there because our graph doesn't reach that. So that is 8.3. Let me know if you have any questions.